Okay, so quickly before the video starts, I just wanted to let you guys know that while editing the video, I ran into some technical issues and I'm late again.
Well, guess who's back, suffering from a cold and has the time to waste on a stupid intro? This guy. Wait, that's not right. Step 1. Go to YouTube. Step 2. Search for Garbage. Seriously though, for all your FPS needs, I can't recommend a channel better than Garbage. But hey, you came to me for a tutorial and you'll get one. Let's get over with the boring stuff first because we won't be touching it ever again. Input map. Starting with a fresh Godot project, go to your project settings, click on input map and start typing the input actions we'll be using, namely forward, backward, left, right and jump. Next, scroll down to find the actions and add the corresponding keys to each of them. For my example, I'll be using the standard WASD and space keys. Next, go to the General tab and look for the Window section. Here, enable the full screen option if you want the game to run in, well, full screen. Now, let's set up the... For this tutorial, we'll only need two scenes, one for the player and one for the overworld to play around in. I already have this scene prepared as the overworld. Oh, by the way, you can find the link to the project in the description down below. Now, let's create the scene for the player. We'll set the root node to be a kinematic body, which is one of the mainly three physics bodies in Godot, the other being static and the rigid body. I'm using the kinematic body as it provides the most control over the physics of the player. Now, let's add a collision shape as its style and set its shape to a capsule. Set the rotation along X to 90 degrees and the height to 2. Then, move the collision shape to sit on the grid. Next, add a spatial node as a child of the kinematic body. This will be the head of the player. Let's add a camera to the head and move it up a bit. Free tip, you can hold control while moving it to snap to the grid. Finally, let's save the scene and head over to the world scene. Here, select the scene root node and press Ctrl-Shift-A or click on this button to instance a player scene. Position the player wherever you want and hit F5 to run the game. Now, if you're running the game for the first time, you may need to select the main scene. Okay, so the game runs and we can see the level, but we can't look around. Let's fix that. Close the game and head over to the player scene. Here, select the kinematic body and add a script to it. The first thing we need to do is set the mouse mode to captured. In the ready function, add this code, save the script and run the game. You see that the mouse is no longer visible, but we still can't look around. Now, before we write the code for that, let's see what we need to do. Remember, when we move the mouse horizontally or along the screen's x-axis, we want the player to rotate along the y-axis. And when we move the mouse vertically along the screen's y-axis, we want the player's head to rotate along the x-axis. Okay, class over, let's write some code. First off, we'll create a variable to store the rotation. This will be a vector 3 initialized with a 0 vector. In the input function, we'll check if the event is an input event mouse motion and then set its relative y to subtract from the rotation's x and the relative x to subtract from the rotation's y. Now, to apply this rotation on the player, let's reference the head node at the top. In the physics process function, set the head's x rotation to the rotation we just said, and set the player's y rotation to the y rotation. Okay, let's try that out. Oh, it's like me at 3 AM after a cup of extra strong coffee. Let's add a way to set the mouse sensitivity. At the top, define an export variable and set it to 0.2. Down in the input function, multiply it by both the rotations, and a player has achieved what I never could, a calm head. Another issue that you'll see is that the player can look beyond the natural angles. Let's limit that. Define two more export variables, one for the minimum and one for the maximum angle of the head. I'll set them to -80 and 90 respectively. Back in the input function, right after setting the rotation, set the x rotation to clamp between the minimum and the maximum angles. And with that, we're done with the rotation part for now. Time to give the player some legs. Okay folks, put your math hats on because we're going to study some maths, cause movement involves maths. Never mind, I'm sick, I can't make jokes. Now, a player can move in 3 dimensions. The motion along the x and the z axis is controlled through the WASD keys, and the vertical y axis is usually governed by the gravity and jumping. So, we're gonna have to code the movement part as well as the jumping/gravity part. Let's start with defining a vector to store the direction of the motion. In the physics process function, we'll set the value of this vector using the getActionStrength method. This is useful for when you want to add joystick support to your game, but mostly it makes the code compact. Make sure to make it normalized as well as rotated along the up axis by the y rotation to make sure the player moves towards the direction we're facing. Next, let's define another vector velocity. Set its x to the directions x and y to the directions y. Why, you ask? You'll see why in just a moment. Pun definitely intended. Now, we'll call the move and slide function and pass it the velocity. It's good practice to store the value returned by the function back into the velocity. Run the game and we have a slot simulator. Time to add another variable to control the speed of the player. Set its value to 10 and multiply it to the velocity. Much better now, but there's still something missing. Smooth motion. Time for yet another variable. This will define the amount of acceleration the motion will have. Set it to 10 and hop down to the physics process function. Here, we'll use the love function to interpolate the current value of the velocity to the desired velocity, which will increment by the acceleration times delta. Do the same for the z-axis and we not only have much smoother motion, but we can also modify it to walk on ice. That's cool. If you were to try to walk off the edge of the platform, you'll notice that we have been in creative mode this whole time. No force in the universe can bring us down, but let's try anyway. Firstly, define a variable called gravity and set it to 50. Then, in the physics process function, check if the player is not on the floor and apply the gravity to the y value of the velocity. Also, we need to pass the up vector in the move and slide function for the condition check to work properly. Well, if you try to tell me now that gravity still doesn't work, I won't fall for it. Get it? I made a fall pun. Well, I guess the joke fell flat. Okay, I'll stop. If you're not a big Souls-like fan, you'd want your player to have an option to jump. For that, we need to define a final variable jump and set its value to 15. Then, in the physics process function, add an LF after the gravity check to see if the jump button has just been pressed, and set the Y value of the velocity to the jump value. With that, our FPS controller is ready for the big leagues. Move over Call of Duty. Of course, there's more things to add. I don't know where I was going with it. That's all there is to this tutorial. I hope you learned something from it. If you want a more detailed FPS controller, I would highly recommend checking out Garbage's channel. As for my channel, I know I haven't been active in ever, but hear me out. I plan on continuing the series of tutorials focusing on more specific things and game mechanics, because honestly, Godot can do with some more tutorials. So yeah, stay tuned if you want to learn more about Godot, or just enjoy a lazy game dev ramble about things he pretends to understand. Okay, bye!